In 1963, the United States and the Soviet Union signed the Nuclear Test Ban Treaty. This agreement drove weapons testing underground, but left a lingering paranoia that covert detonations might be moved into space. To ensure compliance, the U.S. military deployed the Vela Satellite network to monitor the cosmos. These satellites carried specialized instruments designed for one highly specific task: capturing the brief, intense flash characteristic of a clandestine nuclear weapon detonating in a vacuum. At the time, the absolute ceiling of human understanding regarding extreme energy output was anchored strictly to the mechanics of nuclear fission and fusion. The primary signature produced by these violent nuclear reactions is a sudden burst of gamma radiation. Gamma rays are the highest energy, most penetrating form of electromagnetic radiation in the universe, forged when atomic nuclei undergo rapid, violent decay. The scientific team at Los Alamos National Laboratory constantly monitored the Vela telemetry, waiting to spot a sharp, localized spike in gamma radiation originating from low Earth orbit. By setting a tripwire for human weapons, the military had accidentally constructed a detector sensitive enough to capture a cosmic anomaly they lacked the physics to explain. On July 2, 1967, the sensors aboard the Vela 3 and 4 satellites registered a blinding flash of high-energy photons. The Los Alamos team examined the data and found that the radiation signature completely lacked the profile of a Soviet weapon. It had no initial intense flash, followed by the sustained thermal glow that always accompanies a nuclear detonation. By analyzing the fractional differences in the arrival times of the radiation across the dispersed satellite network, astronomers were able to precisely triangulate the source of the flash. The mathematics ruled out the Earth, and then ruled out the Sun. The origin point was billions of light-years away, far beyond the Milky Way galaxy. A standard supernova distributes its explosion as a diffuse sphere, but to be visible from billions of light-years away, this signal operated entirely differently. Classified as a gamma-ray burst, it releases as much energy in seconds as our Sun will in its entire 10 billion-year lifespan. These bursts defy traditional stellar mechanics. They represent a class of highly concentrated, directed energy events capable of crossing the observable universe. How an astronomical event outshines the rest of the universe without violating the fundamental limits of stellar mass comes down to physical geometry. A typical supernova distributes its energy evenly in all directions, creating an expanding spherical shell of plasma and radiation. This process is governed by isotropic diffusion and the inverse square law, meaning the intensity of the radiation drops exponentially as the surface area of the expanding sphere increases. Over vast interstellar distances, a spherical explosion disperses so much energy into empty space that its light becomes faint and nearly undetectable. If the 1967 Vela signal had expanded spherically, generating that level of brightness on Earth would have required an impossible mass-to-energy conversion, breaking the laws of physics. To solve the mathematical paradox, the energy must perfectly bypass spherical diffusion by being confined to an extremely narrow path. Nature balances the equation by taking the explosive output of an entire star and contracting it into a microscopic concentrated beam. Forging a beam of this magnitude requires specific stellar progenitors that exist at the extreme edges of astrophysics. These conditions are met during the core collapse of an exceptionally massive, rapidly rotating star, or the sudden catastrophic merger of a binary system. When two neutron stars violently merge, their crusts shatter and their masses combine, immediately collapsing inward to form a new black hole. In the fractions of a millisecond surrounding this collapse, the core achieves incomprehensible density while spinning at a significant percentage of the speed of light. This extreme rotation generates the core architectural component needed to contain the explosion: intense magnetic field lines. Magnetic field lines are the invisible vectors of force that dictate plasma dynamics, forcing charged particles to flow along rigid paths. The spinning collapse torques, twists, and amplifies these lines to trillions of times the strength of Earth's magnetic field, winding them into a tight cylinder. The dying star weaponizes its own gravity and rotation, constructing an impenetrable planetary-scale gun barrel made of pure, hyperdense magnetism. Inside this core, the collapse compresses matter to the breaking point, generating a chaotic, expanding mass of raw explosive plasma. This schematic shows how the magnetic topology physically traps the explosive energy, preventing it from expanding in a sphere. Like a lens focusing light, this extreme structure forces plasma to travel the single path of least resistance, straight out the poles. This is a relativistic jet. A relativistic jet is a highly collimated stream of plasma and gamma radiation, fired along the star's axis of rotation at 99.99% the speed of light. The magnetic mechanism acts as a cosmic particle accelerator, translating the chaotic collapse of a massive star into a mathematically precise strike. Once the jet breaks through the stellar envelope, it begins its journey across the interstellar void. Because the beam is tightly collimated, its destructive capacity does not dilute over distance, preserving its lethality across billions of light-years. This creates a precise alignment hazard. For a planet to be targeted, it must sit exactly in the crosshairs of the collapsing star's polar axis. Because the jet moves at the speed of light, there is no advance warning. The lethal wave of radiation and the visible flash arrive at the exact same instant. A gamma-ray burst does not deliver a physical explosion. The destruction is executed entirely through an ionizing radiation strike. Ionizing radiation carries enough severe energy to detach electrons from atoms, instantly tearing apart molecular bonds and cellular DNA upon impact. If a burst aligns with Earth, there is zero kinetic impact to brace for, only an invisible, instantaneous wave of atomic-level destruction. When the relativistic jet reaches a habitable planet, it strikes the upper atmosphere in a fraction of a millisecond. Upon impact, the extreme intensity of the beam initiates the immediate catastrophic stripping of the planet's atmospheric defenses. The primary mechanism of biospheric death begins with severe ozone depletion. In a photochemical reaction, the extreme gamma flux instantly converts atmospheric oxygen and nitrogen molecules into toxic nitrogen oxides, erasing the ozone layer. With the ozone stripped away, the planet's surface is immediately subjected to lethal, unfiltered ultraviolet radiation from its own host star. This triggers secondary cascading atmospheric failures. The newly elevated nitrogen dioxide levels gather in the atmosphere and wash out as extreme, highly toxic nitric acid rain. Finally, the chemical reactions generate dense photochemical smog that blocks out the solar spectrum, plummeting the surviving biosphere into a devastating cosmic winter. The gamma-ray burst acts as the ultimate cosmic sniper rifle, silent, invisible, and capable of instantaneous planetary sterilization from across the galactic void.